Hi, today we're going to take a look at similar polygons with similarity statements and scale factors. So, image can be similar to each other, kind of like a picture on your cell phone where you unpinch and pinch it. So you can unpinch and get that picture really big and pinch it down, it gets really, really small. Those pictures stay proportional to each other. They stay kind of in focus. They don't get distorted. That's what's happening here. We have two quadrilaterals, two four-sided figures. We want to list all of the pairs of congruent angles. Well, how are they congruent? Well, whenever you get that picture and make it larger or smaller, the angles within the picture always stay the same. It's the sides that end up changing with each other. So that's going to end up being our scale factor that we're going to be dealing with at the end. So let's talk about what is the same. So I'm telling you that these are similar. Let's figure out and match everything up now. So let's list all the pairs of congruent angles. So we're going to say angle A is congruent to, that has one arch. Let's look for another one arch, W. Angle B is a right angle. What's the other right angle? X. Angle C is congruent to, that's two arches. Two arches is Y. And angle D is congruent to three arches. Three arches is angle Z. Okay, so we just matched up all of our angles. Now we want to create a similarity statement for these two four-sided figures. We could say A, B, C, D is similar. So now we have this squiggle line here. That means similar. Kind of like we have an equal sign and a little squiggle up here. We're just taking the equal sign out. Let's just match everything up. A matches up with W. B matches up with X. C with Y. And D with Z. We now have our similarity statement. Great. Moving on to the sides, these things are going to change. So we want to write a proportion relating each side. So proportion is just a fraction. Let's come up with a bunch of fractions that are all, well, a ratio is a fraction. Proportions when you have fractions equal to each other. So let's create up with all of our sides that are equal to each other. Let's start with AB. We know that AB matches up with, so we're going from one arch to right angle, one arch to right angle, WX. We want to make sure that we keep the same order going. If we went from arch to box, we want to go from arch to box. AB, let's do B to C, which matches up with box to 2. Let's go from box to 2, XY. Let's go from C to D, so 2 to 3. 2 to 3 will be Y to Z. And then we have one more, and that's going to be 3 back to 1. 3 arches to 1 arch, D to A. And 3 to 1 will be Z to W. So here's all of your proportions. Now we're saying that they're equal to each other. And if I told you that they're similar, they have to be similar. Now let's just figure out what is that value of that similarity statement or that scale factor. So let's take a number for each one of these and just fill it into place. AB is going to be 15. WX is 5. BC is 6. XY is 2. CD is 9. YZ is 3. And then DA and ZW is going to be 9 and 3 again. Okay, so this doesn't tell me anything. These two are the same. That's good, but what about everything else? Let's simplify everything. 15 divided by 5, 3. 6 divided by 2, 3. 9 divided by 3, 3. 9 divided by 3, 3. This whole thing simplifies down to 3 over 1, and this is what we call our scale factor. That's how big something grows from one another. And that's using similar polygons and similarity statements and scale factors.